Hey everyone, so today we're going to go over the week 5 worksheet and in particular, question 4, insects from the worksheet. So insects is a standard dynamic method selection problem where we're finding the different classes of different objects and trying to figure out which method it would select within the different classes it's part of. So before we start this going through the different code at the bottom, we should go over the different classes that we see in this problem. So the first class we see is the class insect. And in this class, it doesn't extend anything or doesn't inherit anything, so it's a standalone class. And next we have the class ant, and it extends insect. So that means ant is a child of insect, and they have is a relationship. So ant is a insect, but the relationship doesn't go the other way around. Insect isn't necessarily an ant because insect is not a child of ant. And then we go to the next class that we see, and it's bee, and it also extends insect. So that means it is also a child of insect, and it has a relationship. Bee is a type of insect, but insects are not a type of bee, so that's how it works. And ant and bee are considered like sibling classes. So what that means is they both share the same parent, but they have no relationship to each other. So now that we've established this, we can move on to the code at the bottom. So the first thing we do is we're creating an object I. So just to recap, an object has two different types of classes. As a static class, which is the one on its left, and we have the dynamic class, which is the one on the right. So the main difference is that when executing a code, the compiler will check the static class during compile time, and it will check the dynamic class during runtime. So these are two types of classes, and we create an object called I. So over here, we can see it has a static class of insect. So we're going to put insect here. It has a dynamic class of also insect. We're going to put insect here. So the thing is, the dynamic class has to be either the same or a child of the static class. So they have to be like is a relationship. So we can always check this by asking ourselves, is the dynamic class is a component of the child of the static class? So is insect is a insect. That statement is true. So this is a valid object. So next line is calling a method on I. It's like I.speak. So during compile time, we would want to check the static class of I, which is insect. So we go into insect, and then we check to see if there's a method called speak in it, and we find the method called speak. We don't actually need to execute or see what's inside the method. We just need to know there is a method called speak, and it's good to go under compile time. And then after that, during runtime, you would want to actually execute the speak method. So it goes to the dynamic class, insect. So we go into insect and we look for a speak method, and then we execute what's inside speak method, which is to print the line I am an insect. So if this is a console, I'll print out I am an insect. So great. So that line works. So we can move on to the next line. The next line is creating another object called A. And in this case, it has a static type of ant and has a dynamic type of also ant. And we can check to make sure this is valid. Ant is an ant. That statement is true, so this passes. My bad, this passes. And then we can go to the next line, A.speak, check the method, the class ant. Is there a speak method? Yes, there is. So it works. And then during the dynamic runtime of it, we go into the speak method of its dynamic class ant. So we go to this method and we print out I am an ant. And excuse my bad handwriting, but let's go to the next line where we're creating another object called B, which has a static class of B and a dynamic class of B. We checked B as a B, so this works. The object is created, and then we call B.speak. So during the compile time, we go into the B class and check, is there a speak method? Yes, there is. And then so we can, during runtime, we can go to dynamic class, B, check the speak method, and then go into the speak method, which prints out I am a B. Goes I am a B. So good so far. We haven't had any mismatch types. Like all our objects have been valid so far. And let's go to the next one. So now we're taking the object I again, and we're changing its dynamic type to ant. So we go over here, it's no longer insect dynamic type, and then we change it to ant. After changing it, we want to make sure it's valid. So we try to ask ourselves, is ant an insect? Ant is an insect because ant is a child of insect, or it's an instance of insect. So this new object is also valid, or this new dynamic type is also valid. So let's call I.speak again. So when calling I.speak, we want to check insect for the speak method, and the speak method exists in insect. And now during the runtime, we want to go to ant class and run its speak method. We go to its speak method in ant, and then we print out I am an ant. And pay attention that this is very different from what we called before. Before we called the same method, I.speak, but it printed out I am an insect because it had a different dynamic type. And that's showing how the dynamic type can impact the result that you get when running a program. And now let's go to the next line, I.attack. So now we can go to the static class of insect and look for attack method. But if we look in insect, there is no attack method. So that means there's a compile time error. So this line would not execute and throw an error because there's no attack method in its static type. And next line, we do a thing called typecasting. So what typecasting is, it's temporarily setting the static type of the object or a variable to another type. And only temporarily, and only for that line only. So in this case, we're typecasting I to temporarily be ant. So we want to change the static type to ant temporarily. And then now let's call, and we want to call .attack again. So now since the static type is ant, we want to check the ant class for attack, and we see the attack method here. So we don't have it, so it compiles, and we're able to get to runtime. So when we get to runtime, we'll run ant is dynamic type .attack, which will return ant attacked. And that is great, and because it is valid and doesn't throw an error. So let's go to the next line. So we're taking the object B, and we're setting its dynamic type to insect. And before I go further, I just want to show that since we finished executing that line, insect is no longer ant, or like I is no longer ant, it's an insect again. So now we want to check, is insect a B? Insect is not a type of B, so we get a compilation error here because it's not possible for a dynamic type to be a parent of its static type. And then next line we call B.speak. But and this line would not be possible because earlier we established that we would throw an error if we try to change B to insect, dynamic type to insect. So we say not possible here. And the next line we go to B.move. And like the same thing applies.